It is a good day. Thank you for choosing to learn with me. We shall be exploring number bases. Did you know that number values can be numerically written and read in different ways? Take for example the number value of 15, which is commonly written as 15, with 1 representing one group of 10 and 5 representing 5 ones. This value can be rewritten in a variety of ways to include 1, 1, 1, 1 base 2, also 1, 2, 0 base 3, also 2, 3 base 6. In other words, the possibilities are limitless. I want to draw your attention to these little guys, the subscripts, to include 6, 3, 2, and a silent 10. These are what we are calling number bases. These little guys tell us how to make sense of written numerals. In other words, in them is the power to encode and decode numerals. The question though is, how then do we encode and decode the number value 15 as shown earlier? We shall use manipulatives this time in a method involving grouping and regrouping according to a given base. In my hands are 15 bottle tops. When we think about base 10, we think of regrouping in groups of 10s. And here with me is one group of 10s and 5 ones. This is written as 1, 5. That is the common way of writing. And since base 10 is the commonest base, we usually do not include the base as a subscript. Recall that we earlier said that the same 15 can be rewritten in terms of base 2, base 3, base 6, to mention but a few. Now, thinking in terms of base 2 requires that we regroup the 15 bottle tops into groups of 2s first. So there we are. Good. And this gives us 7 groups of 2s and 1. When we are working with base 2, we do the groupings in 2s. So the available 2s can further be regrouped into other groups of twos. For example, that is one group of twos, another one group of twos, and there we are, another group of twos. So it's like we're left with one group of one group of twos, and herein we have three groups of twos, but each group has four, so we shall say we have three groups of fours. The fours can be further regrouped into twos. So we have two similar groups, and I can group them into two to form one group of 8. So with me, I'm left with one group of 8, one group of 4, one group of 2, and 1, which is written as 1, 1, 1, 1 base 2, which of course equals 15, can also be rewritten in terms of base 3. When we speak of base 3, we think of regrouping in groups of 3s. That means that I'll have to create groups of 3s. There you are, another 3, and there we are, altogether giving us 5 groups of 3s, and remaining with 0 1s. But operating in base 3 requires that we do the groupings in 3s. We therefore cannot leave these 5 groups of 3 the way they are. We have to further regroup into 3 3s. So I have my 3 3s. This leaves me with 2 groups of 3s, 0 1s, and one group of 3 3s, which is the same as one group of 9. This can be rewritten as one group of 9, 2 groups of 3, 0 groups of 1s, all in base 3, implying that 15 is the same as 1, 2, 0 base 3. Still working with our 15 bottle tops, we can go ahead to represent 1, 2, 0 base 3 in terms of base 6. Like we have done right from the beginning. In base 10 we did the groupings in groups of 10. In base 2 we did our groupings in groups of 2. In base 3 we have done our groupings in 3s. In base 6 we shall do our groupings in groups of 6. With our bottle tops together, I could do a group of 6, another good group of 6, and 3. So it's like I'm left with 3 ones and 2 groups of 6, written as 2 groups of 6 and 3 ones, but all in base 6. So this gives us a way of writing and reading numbers numerically in different ways, in a way that the base helps us to make sense of the written numeral, and not only that, but also the base has the power in which we decode the written numerals. The bottom line here is knowing that the base we are using gives us a way of grouping. Having looked at how 15 can be rewritten using different number bases, let's look at the place values of these number bases. The groups, or rather the groupings in each number base, gives us a basis for place values. Look at this table and look at the first row, in which we have the common base, that is base 10. In base 10, the groupings are done in tens, and the least possible place value is 1, followed by tens, 10 tens, which are hundreds, 10 tens, which are thousands. The same method applies to all the other bases. If I look at base 2, which is our third row, we have ones as the first place value, followed by twos, since we're working in base 2, followed by 2 twos, which is equivalent to 4s, followed by 2 twos, which is the same as 8. I encourage you to take some time to study the table and complete filling in the blank spaces. You may also think about other bases not listed here, to include base 9, base 11, base 12. Number bases have an application. The most known application of number bases is in computer programming. Computers do not understand our usual language, rather it's in base 2, as in every piece of data is encoded using ones and zeros. Not only that, we see number bases in measuring inches and feet. It is known that 1 foot is 12 inches, and therefore if you're adding, let's say, 2 feet and 7 inches to 3 feet and 8 inches, you have to put in mind the number base in adding the inches to be 12. We also use number bases in coding messages. Let's take an example. Suppose we code letters of the alphabet using numerals in base 6 to write a message. First of all, I have encoded each letter using numerals in base 6, and we can see that A is 1, whereas E is 5. Now in F, instead of writing 6, we go back to 1, 0. And Z will be 4, 2. Think about this message by simply using the table above to fill in the letters. Take some time to pause the video and write out this message. Thank you. This message would mean math is fun. Imagine the power you could have writing messages to people, but without others knowing what you have written, and keeping the best you have used to yourself and to the person you have communicated to. It would be really fun. I would like to challenge you to use coded letters of the alphabet using numerals in base 5 to write I love mathematics. You could write other messages to me. If you're using another base other than 5, make sure you tell me which base you used, and let me see your responses in the comments section below. Thank you. These are some of the references I used. Math is fun. That link is very good. Education in the UK. Thank you for your time. Thank you for being with us. Thank you so much. Subscribe to my channel to be among the first to be notified whenever I drop in another learning video. Our next video will entirely focus on teaching number bases. Thank you so much.